have the notes there. A little different format today. You won't see me in formats of notes like this. Most of the ones that we have are going to be very similar to what you've got already. Reminder. Let me ask this: how many preferred some of the things in the notes yesterday? Look at it up. Okay, they're there for you. That's your purpose. Use them. Okay. Again, we'll do note checks all the time, so make sure you're taking good notes. I don't think it's going to take too terribly long today. So let's get started here, guys. We're going to start looking at not dealing with equations anymore, but we're going to be dealing with writing and graphing. What's this word right here? Inequalities, okay? What kind of signs do inequalities involve? If I go all water boy on you and start talking about alligators.
What are you talking about?
Well, sometimes
She was right.
my mom always said that alligators are so angry because they have all those teeth and no toothbrush. You not heard that before?
No. Yes.
Water boy? Huh?
Good movie.
Yeah. Okay. Yeah, inequalities deal with what kind of signs again, Madeline? I didn't hear you.
Greater than.
Less than.
Greater than or equal to.
Greater than or equal to.
Less than or equal to.
Very good. Less than or equal to. Okay. So today the question we want to be able to answer is this: how can you use an inequality to describe a real life statement? That's what we're looking at. Okay. Now, right here it says that we can go to bigideasmath.com for an interactive tool to investigate this. I'll get there in a little bit, but we're just going to kind of work together. We're not going to work with a partner. We're going to work together. We're going to write an inequality for each statement, and then we're going to sketch a graph of the numbers that make each inequality true. Okay. What I'd kind of like to do right over here, kids, is this. I'm going to kind of put a line over here, and maybe a line right here. I want you to write down the word toolbox up here. Okay. I'm going to put down some information. First of all, how do you read that sign right there? That's a greater than. As I read left to right, this is a greater than sign. Okay. My next one, how do I read this one? Less than. Okay, and I think you probably know this already, but I just want to write this down as a quick reference. So less than. Okay, what do you think this one means then? Greater than or? And I'll kind of abbreviate. Greater than or equal to. And then the last one, what's the last one going to be up here? Last one will be less than or what? Okay, now I'm going to do this real quickly because I think it's very important. Anytime we have to start looking at these graphically, and then especially writing them too, but anytime we look at these graphically right here, I think it's very important to understand that these signs have an effect on how you start something graphically, okay? What I will tell you is this. Anytime you have to start with a sign graphically with greater than, you always put your dot on the reference value, but this is going to be an open dot, okay? It's kind of like saying, I'm going to start at some number. Pretend we say like x is greater than 3. You're going to start at 3, but you're really not going to include 3, okay? So this means you're going to start there but not include it, all right? Same thing with less than. You would start there but not include it. That's how you represent that. So if these are open or not shaded, what kind of dots are these going to be for greater than or equal to? Okay, and let me talk about this real quickly. These shaded dots mean you want to include the value as part of your solution. A shaded dot, or a closed dot as I always call it, is something that will be included in all this all the time. So, that being said, I just want to throw a quick question up here. Inequalities, when you're making comparisons, are very easy. What we're going to look at today is how do you model some real life problems by writing an inequality. That's the part I think that's difficult for kids when we get to this level. But we're going to practice that a lot today, okay? Before I run off to the second page, just double check, make sure you've got your little toolbox over there as I have it up there on the board. Oh, y'all okay right now? Who said no? Millard, what am I going to do with you? You good now? Getting there? Oh, okay. Do you have all that down though? Serious? Okay. Everybody else have that down? Okay, real quickly. Quick question. You don't need to write any of this down. Is this first statement true or false? It's false. It's like saying 3 is greater than 3. That's not true. 3 is actually equal to 3. So there's a difference between here. How about this statement? It's true. What part makes that true? I'm sorry, I didn't hear you. You gonna show again? What makes that true again, Bree? Okay, that bottom part, the equal sign does. Okay, so I think that we've kind of seen the comparisons of these before. We know what they mean. We know which statement is true, and we know which statement is false. Up here you said false. 3 is not greater than 3. It's actually equal to 3. So this part right here, that makes this part true. Okay, let's see if we can't figure out what's going on here. Let's look at example 1 here to start. It says, in that part where we're going to work together, write an inequality for each statement, and then sketch a graph of the numbers that make each inequality true. How about a volunteer to read statement A for me? Volunteer to read statement A for me. Have it right in front of you.
I think Matt should do
Matt, you want to read that one? You've been nominated. Read statement A.
The temperature heat in sweat is at least -10 Celsius.
Negative 10 Celsius. Okay, I'm going to underline a phrase right here. It's at least. It doesn't say greater than, doesn't say less than, doesn't say greater or equal to, it doesn't say less than or equal to. Okay? What the heck does at least mean? If I use the phrase at least in something, what the heck does that mean in terms of inequalities? Thought, Sydney?
like it'd be
Greater than or equal to. Listen to this. Who can I pick on right now? Who has money on him right now? Matt. Who has money on a cereal right now? Okay. Sid, you started this. Okay, listen to this right now. I'm going to say Sid has at least $15 with her right now. Sydney has at least $15 with her right now. What am I implying right here when I say she has at least $15? How much might she have?
30.
She could have 30. Is it possible she could have 15? If I say she has at least 15?
No.
Okay, it is. She's got at least 15. At the very least amount of money, she has 15. That means she could have 15 or
Less.
not less. The very least, when I say at least, it means the absolute lowest that I have is $15. She might actually have more than that. So I want to make some notes up here. This phrase at least in this right here, kids. At least typically means the following. It means you have equal to that value or more. So when we say the temperature in Sweden is at least negative 10 degrees Celsius, kids, what variable are we using here? We're saying the absolute coldest it gets in Sweden is negative 10 Celsius. So the temperature T related to that has to be either greater than or equal to negative 10. Okay, so that phrase, at least, actually means what, kids? What's this sign again? Greater than or equal to. So to graph that, kids, greater than or equal to is in here. Where am I referencing from? What value are we comparing temperatures to in this problem? Negative 10. So I'm going to put a dot on negative 10. Is my dot going to be open or closed on negative 10?
closed.
It's an equal sign, right? So it could include it. So we want it to be closed. We want to include that. So anytime I close that right here like this, we're including it. Now, are the temperatures going to be warmer or less than negative 10? It's going to be warmer, right? When I say it's at least 20 degrees out, it means it's 20 degrees or what? Warmer. If I say I need at least 10 people to help me, is 7 going to cut it? No. I need 10 or what? So at least means greater than or equal to. So to indicate all these numbers that could be Warmer than this, we would shade to the right, okay? Let me ask a question. Could the temperature be 30 degrees based on my graph? Yeah. Could it be negative 30? No. All these shaded values right here represent solutions that would satisfy this statement right here, okay? All right. Let's talk part B. It's kind of hard to read up here, but you guys have it in front of you. Part B statement says the elevation of Alabama is at most how many feet? I love Alabama.
Yeah.
Greatest racetrack in the world down there that I like to visit. Anybody know what racetrack I'm referring to?
Alabama.
They made a movie about it. I got to sit there in the stands and watch them film part of this movie as they dived across the finish line.
Forrest Gump.
Not Forrest Gump. It's a movie about NASCAR.
NASCAR.
Talladega Nights, yep.
They
Okay.
just sat there and watched the film.
I watched them. We were there in 2006. We watched them run across the finish line, do the stuntman dive. How many have seen Ricky Bobby's show? Little Ricky Bobby shake and bake. If you ain't first, you're last. All right. You know what I'm talking about. Love me the Talladega Superspeedway. Yep. All right. Says the elevation. The highest part in Alabama is how many feet?
2004.
Says that's at most 2,407 feet. If I'm 2,407 feet in the air, can I go higher up there in Alabama, or is that the highest we can go? So when I say you're at most this height, it means every other height has to be above or below that. So how about this phrase "at most," kids? What does this really mean? It means less than or equal to. Okay. So we're using the variable e. We want my elevation e to be less than or equal to what value, kids? 2,407. Okay. This is really talking about the elevation above or below sea level. By the way, I have a question. Does sea level ever change? Think about it. Aren't the oceans either rising or falling? And over time, isn't average sea level, would that ever change? I don't know. I don't know the answer to that. Would you guys do me a favor and ask your science teacher today? Ask them if the elevation ever changes. Because if the sea level changes, wouldn't the elevation of highest and lowest points change too? It would, wouldn't it? Because if your sea level, hey, here's our school. Our school's sitting right here. Okay, but if the sea level would rise, does that mean our elevation would fall then, wouldn't it? Does that make sense what I'm talking about?
Yes.
Ask your science teacher, I want to know. Or somebody just Google it up for me right now. Does the sea level ever change?
It is. It's rising. Yeah.
It is?
Climate change related.
So that means the elevation of all of our locations must be doing what then, if the sea level's rising? Must be falling down, right? Huh. Oh, that's a lot of thinking for first hour on a Thursday, right?
Yeah.
Okay, let's talk. How would I graph this, kids?
You wouldn't.
Well, what value would I reference first? Now, 2,407 doesn't show up exactly on the line, but let's reference it. Would I be open or closed based on this sign? Look at your toolbox over here. Closed. We want to include 2,407. Closer to 2,000 probably than 3,000. Start here. Then I want elevations to be less than that reference value. So am I shading to the left or shading to the right? Left. To the left. To the left. There it is. That would be a graphical that we would represent. Now, here's the deal. I think you can kind of understand what's going on here, but I don't want to make this difficult on us, all right? Let's make sure we remember how to write inequalities for graphs. Down here in Exploration 2, we have to write an inequality for each graph. And then in words, describe all the values of x that make it true. I'm not going to worry about the wording part of it. What I am worried about is, can you look at a graph and can you write me an inequality? Okay, most times when we don't know which variable to use, we typically choose what? Okay, so we'll choose x. First of all, what's your reference value in this graph, kids? 1. Is it open or closed on 1? It's closed on 1. So will the sign that we choose for the inequalities have an equal sign under it or not?
Yeah.
It will, won't it? Okay. Anybody have a thought what that inequality might be if I have to write an inequality for that given graph? Bradley, what do you think, kiddo?
X is greater than or equal to
Yep.
11.
X is greater than or equal to 1. And if you weren't sure, I could check. Aren't some of these values to the right of 1 shaded? For instance, isn't 4 in that shaded value?
Yes.
Indicating that anything in a shaded region is a solution. So if I choose something from over here, let's say I pick the 4 to plug in right here. Guys, if I would plug 4 in there, does that give me a true solution or false solution? True. 4 is greater than what?
1.
1. So yes, you're correct there. Let's look at a few more. Okay? Anybody need more time, page 1?
No.
All good?
Yeah.
Give me a thumbs up if you're good. All right. I even got 2 thumbs up out there. That's awesome.
You got about half a thumb right.
You guys try. you guys.
I'm not even kidding.
You guys try B, C, and D on your own. Make sure you've got it when you have all those solutions. Check with a neighbor. If you guys disagree about something, talk about why you disagree. Okay?
Whoa.
Whoa, whoa, whoa!
I
Page
was on the
2.
wrong page.
That's not good, Sid.
Done.
Maddie, I see this. Good. Who doesn't have one?
Oh. See?
Yeah.
Yes. Yes, we're fine.
All right, kids, you ready to roll? I should see every single appropriate digit in the air right now, but what's the inequality for this top one? Volunteer, please. Mr. Jacob.
There's small.
X
X.
greater than 1.
Beautiful. Okay. How many agree? Next one. Go, Kylie.
X is less than or equal to 1.
Why less than or equal to? Why do you have the equal to? Because it's shaded in. Very nice. Who wants the part B? Go ahead, Matthew.
X is less than 1.
Beautiful. Okay, so we're good at this. We know how to do this, all right? I have a question. How come you didn't write this down as 1 is less than X?
Because X goes first.
Okay. You always want to put the variable first. When you're writing these, always put the variable first. If you notice right here, if you put the variable first, if the variable's first right here and then the number is over here on the right, doesn't the way the inequality sign points match the direction of the sign?
Yes.
But that's only true if what's listed first?
Variable.
The variable, okay? That's only true if the variable's listed first. So this here is just a bunch of phony baloney. Bunch of hippy dippy baloney right there. Don't do that, okay? All right, let's talk. Communicating answers. Want to make sure that we're okay with this, all right? It says, how can you use inequality to describe a real life situation?
Statement.
Okay, I can make a statement right here. In this class, I have 16 kids.
1, 2, 3.
Actually, there's 17 when Carly joins us. Okay?
Here.
But, here's the situation. Here's the situation here. Could I make a statement up about the number of kids that are in first hour math class with Carson? What could I say?
There are at least 16, at most 17 kids.
I take that actually. At say it again.
At
At
most
most.
17.
So that means X is less than or equal to 17. Would you guys agree with that? Now I can't say at least because that would mean 17 or more, right? So you said, how can you write inequality to describe a real life statement? You might say, say it again for me, Dallas.
There are at most 17 kids in the class.
At most 17 kids
in Parsons. First hour class. Means the number of kids in here, K, would have to be less than or equal to what, kids? Well, 17. Okay? If somebody's sick one day, can that number go over 17 or does it fall below 17? So we want our comparison of the number of kids to be either less than 17 if someone's gone or right at 17 if everybody's present. Make sense?
Yes.
Okay. How about this? The Cleveland Indians. They have baseball fans in here today. Okay, Jacob, what did Cleveland just do yesterday? They won their 21st straight game, tying a major league record for the most consecutive wins ever in the history of the game, which is phenomenal. Okay? They play again today. You know what? They have a chance to do what? Win again. We could say their winning streak is at least how many games? 21 games. That would be like the number of wins, W, right now would be greater than, or I should say the number of consecutive wins, W, would be greater than or equal to 21. Okay? Unheard of. Unheard of. Okay? The only thing that frustrates me about it is the Twins are in our division. That's frustrating. Okay? But Twins are holding down that second wild card right now. So we're still in the race. Okay? All right, write a real life statement that involves the inequality. It's pretty easy to do. I could say, how many of you are in a standards-based grading class? Anybody in there, standards-based grading? Is science standards-based grading like a 4-point scale instead of percentages like in here? Okay, apparently you don't know yet. Okay, won't talk about it. Let's just worry about this right here. I'm not going to worry so much about writing a real life statement that involves each inequality, but I could just say something like this. I could say that maybe, the number of kids on average that come to chess club is less than what? 3.5. By the way, any chess clubbers in here? Any chess players? Oh, come on.
How about checkers?
Checkers. Well, we can get there. Okay. I'm going to worry about graphing these right here, kids, making sure we understand how to do this. If I had to graph x is less than 3.5, I don't ask you to get too particular about the graphs. Just put a line here. What value am I comparing all of my numbers to? What value am I comparing all my numbers to?
3.5.
Okay. Now, if I wanted to shade all x values that are less than 3.5, the first question is, on that reference value 3.5, are you open or closed there when you represent this graphically? Open, right? There's no equal sign here. So it's like saying start at 3.5, but I don't want you to include it. Okay? Start there, but don't include it. So it's like saying all x values less than 3.5. Would I shade left or right, kids? Left. Okay? I'm not going to draw the graphs. You guys just kind of tell me what to do. What value would I reference on part B? 6. Would you be open or closed on 6 when you reference that? Closed. We would shade it, include it. Are you going to shade left or right? Left. Okay? Look at this one. Open or closed on -2? Open and to the right. How about down here on D? Tell me what you would do when you reference 10. Closed and shade right. Okay? I think we have that down for graphically. All right? So in part, this is really pretty simple here. Again, things are going to get more complicated as we look at modeling this stuff. But everybody have what they need, page 2? All right, let's move, page 3. So an inequality. An inequality is going to be anything that represents multiple. It's going to be any expression that represents multiple values. Okay? So as an example, if I say like x is greater than 3, I'm talking about all numbers bigger than what? 3. This is really a representation of multiple values. This is saying we're talking about numbers bigger than 3. So you ever hear the word inequality, you just simply say it's a way to talk about multiple numbers. We compare it to something. It represents multiple values.
Okay? A solution of an inequality is simply any value that makes the inequality true. Okay? On a graph of an inequality, a solution of an inequality, it's the shaded part on a graph. Okay? The solution of an inequality is a shaded part on a graph. So if you ever hear me say, what's the solution of the inequality? Say, well, it's all those values in the shaded region. Okay? If I ever ask, is a value a solution, you're just going to look at the graph and say, well, it's in the shaded region, so yes. Okay? And then a solution set. Solution set is just like comparing x less than 4. Okay? That's your solution set. And then a graph, I don't need to tell you what that is. You know what that is. All right? Don't need to talk about this. You should know that. Do you guys have that stuff written right there? It's a pretty easy section. Okay? In fact, this might be the easiest section we cover all year. Are you ready for next page? Yachty or natty? Okay. All right, so then we start running into stuff like this, and this is where things get pretty important for us. This is the part I really want to focus on. So I'm going to, at the top of this is the 4th page, isn't it, kids? I'm going to say that this is where things start to become pretty important to us. Okay? Right here it says, in these following that we're going to look at here, write the sentence as what, kids? Write the sentence as what? An inequality. Okay. This is where things get pretty important to us. I want to make sure we know how to do this, and I think that everything is pretty much right in there. But it says 12 is what, guys? Greater than or equal to 5 times the number what? N. Okay? Anytime you see an equal sign right there, or I'm sorry, see is, the word is, put that equal in there. Okay? Or say, this is where things are going to kind of break. We used to put equal signs in here and saying everywhere that word is at in a statement. That's the part where we're going to throw your inequality in there. So what value is going on the left, obviously? Are you done? What value is going on the left there, kids? 12. Okay, 12. And then greater than or equal to looks like this. What's going to go on the right, kids? What's going to go in on the right? 5n. 5 times the number n. Okay. What I'd ask is you try 2, 3, and 4 on your own quickly. Okay. It looks like some of you are ahead of me already, but try problems 2, 3, and 4. Find that word is, draw a divide mark, and then figure out what's on the left, what's on the right, and where that divide mark is. Determine which of the inequality signs you need to put in there. Okay. I need a volunteer to head up. Write down number 2 for me. Jacob, go. Pretty cool, isn't it? I'm sorry, 1/3 h less than 1.5. Or is that 15 or 1.5? 15. Are we cool there? Very good. Jacob, hand off to someone for 3. Maddie, have you got this one?
Yeah.
Okay.
Oh shit.
7. Less than or equal to. Why q minus 6 there, kids? What word tip do you off for subtraction? Difference. Very good. Maddie, hand off to number 4.
What's it?
Okay, 4's a tricky one. It's really tricky. You up to the task, Sydney?
No.
Yes, you are. I'm listening. Said the sum of a number u and 14 is more than 6.
I don't like this. It's broken.
Yeah. Operator error.
What's the question?
Greater
6.
than. All right, I
Okay.
like that. Why are you using greater than?
Because it's more.
Greater than means more than. Same thing. Very good, guys. Very good. I can't fool you, can I?
Mic drop.
All right, mic drop. That's awesome, Sid. Good job.
That was stern.
Okay. Hey, are we okay on those 4? Any questions about those 4 right there? I think that you should be able to take some kind of a verbal statement and write an inequality out of that verbal statement. Okay. All right. Last couple of parts right here, and then I'll turn you loose on some things today.
Wait.
Right here, guys, it says in the following: talk about whether the value is a solution of an inequality or not. If they ever, yeah.
On the one that Madeline did,
Okay.
I put the Q before the sign.
So did you write q minus 6 like this again?
Mm-hmm.
Okay. So you always want to read stuff left to right. Now I will tell you this is okay, but you want 7 to be less than this mess, right?
Mm-hmm.
Do you have less than or equal to as your sign, or do you actually have this?
That.
You do have the greater than or equal to like that? Then that's fine, yeah, because think about it this way. If I have 4 and 3, when I compare 4 and 3, which number's bigger?
4.
So if I switch the 3 and 4 around in the order, if I switch the right side with the left side, in other words, what happens to the direction of the sign?
Flips around.
It flips around. So absolutely. If you say, well, mine doesn't look exactly like that, but if you flip stuff around, you have the same expressions on both sides, and your sign would be opposite of what maybe Madeline wrote here in number 3, then absolutely that'd be correct too. Okay? Great question, Sid. I can't fool you. You're just too good at this stuff. Okay? Yeah, you are. Okay? Anybody that wears an Iowa shirt has to be a leg up on everybody, right? Okay? Right, Bree? Right, Bree?
Iowa is way better.
All right, let's roll. Number 5 talks about, is something a solution or not? Take a look at this right here. It says d minus 7 is less than what? 12. But we want to know if d equal 19 is a solution. So they're simply saying substitute 19 in there. So let's do that. 19 minus 7, less than 12. Guys, when I do my calculation over here, what's the left side become? 12 is less than 12 is my comparison.
False.
How about the validity of that statement? It is false. 12 is not less than 12. It's actually equal to 12. So the way it's written when we say 12 is less than 12, is that statement true or false? The statement is false. So if I say, hey, this is false, kids, is 19 a solution? Okay, so up here by 19, I'm going to say no. All right? How about number 6? They want to know if n equals 1 is a solution. Give me a show of hands when you think you have an answer. Is 1 a solution there? What do you think, Bree?
Yeah.
Why are you saying yes? What do you get when you substitute 1 in for n on the right side? 9. When I substitute 1 in here, what is 3 times 1 again? 3 plus 6 more is my 9. What part makes this true, actually? equal sign. You bet this is true. Therefore, is one a solution? You would say yes. Okay. I know I'm going quickly, but are you with me right now?
Yeah. What the heck?
My computer's the Conor McGregor in this little fight right now. I'm glad none of you guys are snappy grabbing my pose right now. That's a good thing. Anybody know what just happened? Because it scared me half to death. All right, last page. I think we're okay. We're going to stop there. Okay, we don't need to go on with any more of this right there. That's the end for notes, all right? So I'm going to go ahead and stop this here quickly.